Time. It's the fabric of our existence, the silent river that carries us from cradle to grave. We measure it with clocks and calendars, yet it remains elusive and perplexing. We think we know it, feel it ticking away, but time is not what it seems. It can be stretched and squeezed, sped up or stopped altogether. We'll explore relativity, where clocks tick at different rates. We'll venture to black holes, those cosmic monsters that warp time, where time seems to halt. Get ready to have your mind blown as we uncover 25 mind-blowing facts about time that will change how you experience reality. Our journey begins with a revolutionary idea, born from the mind of a young Albert Einstein. His theory of special relativity tells us that time is relative. The faster you move, the slower time passes for you. Imagine two clocks, one on Earth and one on a spaceship. As the spaceship nears light speed, its clock slows down. If you think time dilation is strange, buckle up, because we're about to venture into the heart of darkness black holes. These cosmic behemoths possess gravity so intense that nothing, not even light, can escape. As Einstein's theory tells us, where gravity is extreme, time itself gets warped. Imagine approaching a black hole. The immense gravity would pull on your feet more strongly than your head. This would cause time to slow down for your feet relative to your head. As you fell towards the singularity, time would continue to slow down, eventually coming to a standstill at the point of infinite density. From the vast expanse of black holes, we zoom to the smallest unit of time, the Planck time. Named after physicist Max Planck, it's about 5.39 times 10 to the negative 44 seconds. The Planck time is the shortest measurable interval. Before the Big Bang, the universe was a singularity, where all matter and energy were compressed. The Planck time marks the first tick of the cosmic clock, the moment when time itself began. You might think that time is constant here on Earth, ticking away at the same rate for everyone. But even here, under the subtle influence of gravity, time can play tricks. According to Einstein's theory of general relativity, gravity warps time, causing it to slow down in stronger gravitational fields. Atomic clocks have shown that time runs slightly faster at higher altitudes, where the pull of gravity is slightly weaker. This means that your head, being slightly farther from the Earth's center than your feet, actually ages a tiny bit faster than your feet. We all grow up learning that a day is 24 hours long, the time it takes for the Earth to complete one full rotation on its axis. But here's the catch, that's not entirely true. It's actually closer to 23 hours, 56 minutes, and 4.1 seconds. This discrepancy arises because, as the Earth spins on its axis, it's also orbiting the Sun. We often think of time as a linear progression, with the past receding behind us and the future stretching out ahead. But what if this linear view of time is just an illusion? Enter the block universe, a theory suggesting past, present, and future exist simultaneously. Time is like a dimension, much like the three spatial dimensions we experience. Every moment in time exists simultaneously. The block universe challenges our understanding of time and raises questions about free will and reality. We often take for granted that time is the same for everyone, that our now is the same as everyone else's now. But time is not absolute, it's relative to the observer. Two observers moving at different speeds or in different gravitational fields experience time differently. This is the relativity of simultaneity. There's no universal now, no single moment in time. We rely on relativity every day. GPS wouldn't work without accounting for relativity. Satellites experience time dilation due to their speed. They're also farther from Earth's gravity, experiencing time faster. Without these adjustments, GPS errors would accumulate rapidly. The Big Bang, the moment some 13.8 billion years ago when the universe burst into existence, is often described as the beginning of time. But what existed before the Big Bang? According to the Big Bang theory, time itself came into existence with the universe. There was no before the Big Bang, just as there's no north of the North Pole. The nature of time before the Big Bang remains one of the greatest mysteries in cosmology. The concept of now seems straightforward, fundamental to our experience of reality. But as we delve deeper, we find now is not so simple. Imagine two people on opposite sides of Earth looking at the same star. They say, that star exists now. But the light took time to reach Earth. They see the star as it was in the past, not now. The vast distances of space mean we see objects as they were when the light left them. Looking at distant galaxies, we're peering back in time, witnessing events from millions of years ago. Somewhere in the universe, we could see dinosaurs roaming Earth with a powerful enough telescope. Time travel, long a staple of science fiction, might not be as far-fetched as we once thought. Traveling to the future is not only possible, it's something we're all doing right now, albeit slowly. Time dilation means time slows down at high speeds. A spaceship traveling near light speed could fast-forward us into the future. Imagine boarding a spaceship and returning to Earth after decades or centuries. When we gaze up at the night sky, we're not just seeing twinkling points of light, we're peering into the past. The farther away an object is, the longer its light takes to reach us. This means the most distant objects are the oldest. By studying them, we witness the early universe as it was billions of years ago. We take for granted that a day is 24 hours long, but the Earth's rotation is not constant. Over millions of years, the Earth's spin has been gradually slowing down, primarily due to the gravitational tug-of-war between the Earth and the Moon. This slowing rotation means that days are actually getting longer, albeit at an incredibly slow rate. Scientists estimate that the length of a day is increasing by about 1.8 milliseconds every century. Back in the time of the dinosaurs, for example, a day was only about 23 hours long. The Earth's rotation is gradually slowing down, making our days slightly longer. This affects our highly accurate atomic clocks, which define the length of a second. To sync atomic time with Earth's rotation, scientists add a leap second. These are added at irregular intervals when the difference becomes too great. The last leap second was added on December 31st, 2016. We humans experience time at a particular pace, but did you know that other animals perceive time differently? Flies, for example, with their super-fast visual processing, experience time in slow motion compared to us. This means that a fly buzzing around your kitchen sees the world in a completely different way than you do. To them, your attempts to swat them away seem like slow, lumbering movements. Other animals, like sloths, have much slower metabolisms and movement patterns. To them, the world might appear to move at a much faster pace. Today we take for granted the concept of time zones, with the world divided into 24 zones. For most of history, time was local, determined by the sun's position. In the 19th century, railroads needed accurate schedules, leading to standardized time zones. This was a major achievement, enabling coordination across vast distances. Wars are often protracted affairs lasting for years or even decades, but the shortest war in recorded history was over before it even really began. The Anglo-Zanzibar War, fought between Britain and Zanzibar on August 27, 1896, lasted a grand total of 38 to 45 minutes. The conflict arose from a dispute over the succession to the Zanzibari throne. The British responded with overwhelming force, bombarding the Sultan's palace and sinking several Zanzibari ships. Have you ever noticed how time seems to speed up as you get older? The summers of childhood seem to stretch on forever, while the years now seem to fly by in a blur. As we age, our brains process new information less efficiently. With fewer novel experiences, time blends together. Another theory is that time perception is relative to lifespan. To a child, a year is significant, but to an adult, it's just a fraction. You're walking down a dark street when suddenly you hear footsteps behind you. Your heart races, your senses sharpen, and time seems to slow. This is tachypsychia, a real response to threats caused by adrenaline and other hormones. These trigger physiological changes like increased heart rate and heightened senses. Your brain processes time differently, making it seem like slow motion. Calendars have been around for millennia, marking seasons, planning futures, and recording history. The oldest known calendar, found in Scotland in 2004, predates others by thousands of years. This calendar, with 12 pits in an arc, is over 10,000 years old, from the Mesolithic period. Its discovery offers a glimpse into ancient timekeeping practices. While the concept of time is fundamental to Western cultures, it's not universal. Some indigenous cultures, like the Amandawa, have no concept of linear time. They see time as cyclical, tied to seasons, the moon, and the river. They focus on the now and nature's cycles. This challenges our assumptions about reality. For centuries, we defined a second by Earth's rotation, dividing the day into hours, minutes, and seconds. But as our needs grew, we needed a more accurate standard. Enter the atomic clock, using atomic vibrations for incredible accuracy. In 1967, the second was redefined by cesium atom vibrations, providing a stable, accurate standard for timekeeping, advancing GPS, astronomy, and research. From the vast expanse of the cosmos to the subatomic realm, we've explored time, uncovering its secrets and challenging our perceptions. We've seen how time is relative, warped by gravity and velocity, and how our experience is just one perspective. We've journeyed to black holes where time slows to a crawl and witnessed the birth of the universe. Time is not a constant, but a dynamic force shaping our universe. So the next time you check your watch or glance at a calendar, remember, time is not just a measure, it's a mystery, a paradox, and an endless source of fascination. Time, the ultimate enigma. From the ticking of a clock to the grand cycles of the cosmos, time is woven into our existence. It's the silent conductor of the universe's symphony, orchestrating the dance of stars. Did any of these facts surprise you? Let us know in the comments below. And don't forget to like, subscribe, and hit that bell icon for more videos. See you next time. You're Lisa from List 20+.